here in 8.1 day 12 CAMI assignment. We're solving systems by graphing. Here I have this system made up of two equations, and neither one of them are in slope-intercept form. And so I need to show my work to put it in slope-intercept form. So we'll start with equation 1. Let's copy it down. Negative 6x plus y equals 4. I see the y term is on the left side, so let's get this x term on the right side. And so to move it, I have to add 6x to both sides, add 6x to both sides. So these 6x's will cancel, right? Negative 6x plus 6x, those cancel, and you're left with just y equals, bring your equal sign down, right? Put the x term first. The x term is 6x, and then put the constant term. The constant term is 4, or positive 4. And so this right here is your equation in slope-intercept form. And so now you can identify m. M is the number in front of x, and so that would be 6. Or if you write it as a fraction, it's 6 over 1. The constant is your b. B is the y-intercept, of course, that is 4. And so if we go to graph this equation, I begin with b. And on the y-axis, of course, that's x-axis, and this is y-axis. On the y-axis, I have b of 4. And so that's where I begin. And then I move with m. M is 6, or 6 over 1. This would tell me to go up 6 and right 1. And so obviously if I do that, I'm going to be off of the grid. And so let's change the direction of both arrows. Instead of going up, I go down. Instead of going right, I go left. And so from B, if I go down 6, left 1, I will be on the same line. So down 6, 1, 2, 3, 4, 5, 6, and left 1. And so right there would be on the line. So let's connect the lines using the line tool, or connect the dots using the line tool. And arrows on the end of your line to show the line continues forever in both directions. And put a 1 and circle it. That's line 1 that comes from equation 1. All right, so we've graphed equation 1. Now let's graph equation 2. Equation 2 is negative y minus 2x equal 4. Y is on the left side, so get this x term on the right side by adding 2x to both sides. So these x terms will cancel, right? Negative 2x plus 2x, that cancels. And you're left with negative y equal to, put your x term first. Your x term is 2x. And then you have a plus 4. Now remember, this is not slope-intercept form yet because this is negative y, or you could say negative 1y. And so to solve for y, I divide every term in the equation by the number in front of y, which would be negative 1. So every term is getting divided by negative 1. Okay, so that these negative 1s will simplify to 1y, or just y. And so y equals, here I have a 2 over negative 1. 2 divided by negative 1, that is negative 2. Don't forget the x term. Here I have 4 divided by negative 1, which is negative 4. So this right here is the equation of the line in slope-intercept form. And so now you can identify m. Here's m, negative 2, or negative 2 over 1. And b is negative 4. Okay, so look at their slopes. Their slopes are different, right? This slope is 6, this slope is negative 2. So different slopes, I expect one solution. The lines will intersect at exactly 1 point. So to graph line 2, I begin at b. B is at negative 4. B is at negative 4. So on the y-axis, I put a dot at negative 4. Okay, right there. And then the slope is negative 2. Okay, so negative 2 over 1. This would tell me to go down 2 and to the right 1. And so if I begin at B and go down 2, I'm off of the grid. And so like we have done, let's change the direction of both arrows. Instead of going down, I would go up. Instead of going right, I would go left. So down to the right is the same thing as up and to the left. So from B, from negative 4, let's go up 2, 1, 2, and left 1. And as you can see, that point right there is going to be on both of the lines. So insert your line here, click and drag to connect those dots. Okay, arrows on the end of the line to show that the line continues forever in both directions. put a 2 and circle it. That's line 2. Line 2 comes from equation 2. And so this point right here is the intersection of the lines. So from the origin, how do I get to this point? From the origin, I would go left 1. And if I go left 1, that is negative 1. I'm going to put my comma. From the origin, I go left 1 and then down 1, 2. So down 2, that's negative 2. So this point right here, negative 1, negative 2, is the solution to the system. This is the only point that is on both lines. From the origin, I went down, or left 1, down 2. Left 1, down 2, negative 1, negative 2. Here's system number 2. System number 2 is made up of 2 equations, equation 1 and equation 2. Neither one of them are in slope-intercept form. And so let's put them in slope-intercept form. Equation 1, I have negative y minus 3 plus 4x equals 0. Okay, now as you can see, the y term is on the left side. And so I could certainly move the negative 3 and the 4x to the right side. That would certainly work. Or I could move this y term over here on the right side of the equation so that it would already be by itself. And so let me do that. Let me add y to both sides so that these y's will cancel, right? Negative y plus y, those are gone. And so you're just left with negative 3 plus 4x. Let me go ahead and write the x term first so that it will be in slope-intercept form. So the x term will be written first. And then here's my constant. That is a minus 3 or a negative 3, I could say. Bring my equal sign straight down. And over here you have 0 plus y. That is just y. Okay, I could also write this as y first, right? Y equals 4x minus 3. Both of these are saying the exact same thing, right? This is the same thing as this. Okay, but normally you see y equals and then your x term and your constant term. So here in the slope is 4, or I could say 4 over 1. And then my constant term, negative 3, that is b. So b is at negative 3. So if I graph line 1, I begin at negative 3, I begin at b. This is the x-axis, this is the y-axis, and so on the y-axis, I begin at negative 3. So here is negative 3 right there. The slope is 4, or 4 over 1, right? 4 over 1, which tells me to go up 4 and right 1. Up 4 and right 1. So from B, up 4, 1, 2, 3, 4, and to the right 1. And put a dot. Okay, I could do that again. Up 4, 1, 2, 3, 4, and right 1. Okay, insert line, click and drag. And what do you put on the end of the line? You put arrows on the end of the line, right, to show that this is indeed a line that continues forever in both directions. On the end of the line, put a 1 and circle it. That is line 1 that comes from equation 1. Okay, so now we got equation 2. It's not in slope-intercept form, so let's put it in slope-intercept form. Equation 2, I'm just copying it down. It says negative 4 equals negative 3x minus y. Okay, my y is on the right side, so let's get this x term right here on the left side by adding 3x. I add 3x to both sides, so those 3x's cancel. And over here I have 3x minus 4 equal to, this is a negative y, so I have negative y, or I could say negative 1y, right? Because there's an invisible 1 right there. And so to solve for y, divide every term by the number in front of y, which of course is negative 1. So every term gets divided by negative 1. And so when I do that, these y's simplify to just 1y, or y. Okay, here I have 3 over negative 1. 3 divided by negative 1, that's negative 3. That is negative 3. Don't forget your x. And then here you have negative 4 divided by negative 1. A negative divided by negative is a positive. And 4 divided by 1 is 4. Okay, so in slope-intercept form, if I put the y first, y equals negative 3x plus 4. Plus 4. Okay, so this is slope-intercept form. So now the number in front of x, that tells me the slope. That's negative 3, or I could say negative 3 over 1. And my b is 4. That's my y-intercept. So look at their slopes. This slope is 4. This slope is negative 3. They're different, Different slopes, one solution. You know right away these lines will intersect at exactly 1 point. So let's graph line 2 to see where those lines intersect. Begin at B on the y-axis. Begin at B. B is 4. So I put a dot there. Now the slope is -3 of line 2. So -3 over 1. This would tell me to go down 3 and to the right 1. So from B, I go down 3, 1, 2, 3, to the right 1. And that point is on both lines. I could do that again. I could go down 3, 1, 2, 3, right 1, and insert line. Arrows in the end of the line to show that the line continues forever in both directions. And put a 2 and circle it. That's line 2 that comes from equation 2. And so as you can see, right here is where the lines intersect. And so from the origin, how do you get there? From the origin, you would go right 1. And so that's an x value of 1. And after you go right 1, you go up 1. Okay, so that is the ordered pair 1, 1. So 1, 1 is the solution in number 2. That is the only point that lies on both lines. Okay, here number 3 in this system, we have 2 equations. They're not in slope-intercept form, so let's put them in slope-intercept form. Okay, in equation 1, you got -2x minus y equals 1. Y is on the left, so move this x term to the right side by addition. Those x's cancel, and so you have -y equals, put your x term first. Your x term is 2x, right? It's positive 2x. And then put your constant term. Your constant term is 1, or positive 1. Solve for y here, because this is not slope-intercept form yet, because this is -1y, right? And so to solve for y, divide every term by -1. So that these -1s simplify to just y. 1y equals, what's 2 divided by -1? 2 divided by -1 is -2. And then don't forget your x, of course. And then you have here 1 divided by -1. That is, of course, -1. Okay, so you got y equals -2x minus 1. Okay, so this is m. The number in front of x is m, so that is -2, or -2 over 1. And b is this constant term, which is -1. All right, so to graph this line, I begin at b. This is the x-axis. This is the y-axis. On the y-axis, I begin at b at -1, put a dot right there. And then I move with m. M is -2 over 1. So down 2 and right 1. From b, down 2, right 1. Down 2, right 1. Or I could go up 2, left 1. Up 2, left 1. Up 2, left 1. Okay, insert line. Click and drag to connect the dots. And on the end of the line, as always, we put an arrow to show this is indeed a line. Put a 1 and circle it. That's line 1 that comes from equation 1. Line 1 that comes from equation 1. Okay, now let's graph line 2. Line 2 is -6x equals 3y plus 3. So as you can see, my y term's on the right side. So how about I move this 3 to the left side? By subtraction, right? Undo addition by subtraction. So subtract 3 from both sides. Those 3's cancel. And so I have -6x minus 3 equals 3y. Okay. Solve for y by dividing every term by 3. Every term gets divided by 3. So these y's simplify to 1y. So y equals, what's this? -3 divided by 3. That's, of course, -1. And then what about this? -6 divided by 3. That's -2. Don't forget your x. Okay, so as you can see here, this is, if I put my y term first, y equals -2x minus 1. That looks pretty familiar, doesn't it? It looks exactly like this. And in fact, it is like that. The slope is, of course, -2 or -2 over 1, and b is -1. So if they have same slope and same y-intercept, They are the same equation. So if I were to graph this, I have identical lines. They're the same line. And if they have same slope, same y-intercept, if the lines are identical and on top of each other, where are they intersecting? They are intersecting at every single point on the line. And so we would say the solution is an infinite amount of solutions, infinitely many solutions, because there's an intersection at every single point on the line.